This is where it all began, at least the industrial-sized quantities Tesla wanted to bring to other parts of the world. In this one, it's called the electrical transformer, and this was patented November 2nd, 1897. And here's the patent number. But in this one, he shows two coils set up. They call them bifilar coils now, which is a flat coil that's wound on a flat surface. And so you got the transformer that's putting energy out, and you got a transformer that's stepping it down into the currents again. And so in this one, he's got a generator, and he always says it's the generators that he uses to make high frequency high frequency voltages. And in this one, it's usually his capacitor circuit where he's got like an alternator or something that has a high voltage, and it's pulsing through a capacitor to the primary. And so the primary is a few winds around a secondary coil which has many winds, and so the primary will excite the secondary, and if you get it to resonance, as he states, the resonance will make it so that the energy is transferred to this coil, pretty efficiently. And so in this, he has it hooked up to a wire, and it's just like a transmission line to the other one. But this is just the beginning. So this is how he started. In the next patent I'm going to show next, he gets rid of this middle part. Okay, here's where things start getting interesting. This is his apparatus for transmission of electrical energy, May 15th, 1900, and that's the patent number. And so in this one, he shows the same type circuit, and even in his writings in the patent, it has the same resonant ideas and things like that. And so it's just the same thing. You got a generator, one of his special generators, which is the capacitor run to the primary, and an alternator or exciting circuit that flows through the capacitor to make high oscillations. And so you got the primary again, and you got the secondary. And so in this, he's got the secondary attached to a wire that goes up really high in the air with a balloon, which he refers to as D. And so this is going to send the energy out at resonance, because that's the important thing about using these. And that's going to bring it to this other balloon in the air and bring the energy down in the high voltage and bring it down to a lower step down primary. And the primary here is going to run, as he shows, L for lights or M for motors. And this is grounded, and that's important too, that the secondary coils are grounded to ground. So you could have this in one position of the earth, and this thing could be 100 miles away, 1,000 miles away, or the other side of the earth if you could get it, if you get the resonance and efficiency good. Okay, we're looking at the same patent, but I just wanted to say some of the important ideas he said in this patent, and I'm going to read a whole excerpt to you because I can't say any better than how he's saying it. So, in here, in the first pages, he starts talking about how you can ionize the air and how efficiently the air can be ionized, and from what he says, it can be made really efficient, better than copper wires that hold, just like transmission lines. So that's pretty good. And so in the first thing, he starts talking about how William Crookes did, basic experiments with tubes filled with gas, and how, because his was so basic, Tesla has found other ways of making the gases respond even more conductive than Crookes tubes and things like that. So he says that in his classical researches, which have so far served as the chief source of knowledge of the subject, that all gases behave as excellent insulators until rarefied to a point corresponding to the barometric pressure of about 75 millimeters. Even at this very low pressure, the discharge of a high-tension induction coil passes only through part of the attenuated gas in the form of a luminous thread or arc, a still further and considerable diminution of pressure being required to render the entire mass of the gas enclosed in a vessel conducting. And so he goes on and he says, though this is true with his ideas, I have made the properties different with high voltages. And so he goes on to saying that, let me see, I have found that neither the general behavior of the gases nor the known relations between electrical conductivity and barometric pressure are in conformity with these observations when impulses as such as are producible by methods and apparatus devised by me, and which have peculiar and hitherto unobserved properties and are effective electromagnetic forces measuring many hundred thousands or millions of volts. Through the continuous perfection of these methods and apparatus and investigation of the actions of these currents impulses, I have been led to the discovery of certain high important and useful facts that have been unknown. Among these being directly upon the subject of my present application are the following. First, the atmosphere and other gases, even under normal pressure, when they are known to behave as perfect insulators, are in large measure deprived of their dielectric properties by being subjected to the character and magnitude I have referred to, and assumed conducting in other quantities which have been so far observed only in gases greatly attenuated or heated to a high temperature. And second, that the conductivity imparted in the air or gases increases very rapidly, both with the augmentation of the applied electrical pressure and with the degree of rarefaction. The law